we recently, or a couple of years ago, we took a picture of a black hole. It wasn't as simple as us pointing towards a black hole and taking a picture. There's a lot of math and science that has gone behind it. The baseline world model is something we're gonna causally ever accomplish making. And it sounds scary. It sounds like it might give rise to Matrix, a new entirely simulated world or something.
If you are a tech geek with a keen interest in data science, AI, or machine learning, you are at the right link. On today's episode of Beyond Conversations, our guest is a data storyteller, Abhiraj Darshankar. Abhiraj completed his Bachelors in EnTC Engineering from Pune Institute of Computer Technology and went on to pursue an MS in Cognitive Science from the University of Texas at Austin. He currently works as an applied data scientist at Microsoft and is based in Austin. On today's episode, Abhiraj speaks in depth about how data science, AI, and ML systems work in the tech industry. He also speaks about his personal journey of building himself for success in the field. Elaborating on some of the finer details of the design of ChatGPT, he takes us into the future of ethical and resilient AI and the jobs it could potentially create. What do you think are some key skills that data science enthusiasts or freshers should really build up in order to, survive in this industry?
Well, the ultimate question, right? What's the checklist? I don't think there's gonna be a standardized checklist. However, so if you look at any two data scientists in the field, their brains are not gonna be the same. One of them is gonna know more about something else. The other one is gonna know more about something else. What I'm trying to say here is data science is such a vast field that coming up with a checklist will probably set up for failure. But having said that, there are general areas that we need to focus on, general areas of competencies that we definitely need to have. And this stems from first principles thinking again, right? So to be able to do successful data scientist, what is it that we need to do? What are some foundational truths, foundational skills, foundational abilities that we need to hone? What I'd say is there are a couple. We need to learn to code. Why is coding important? So that we should be able to play and manipulate data. We are in a digital world. Data has made a lot of things possible. Statistics existed before data. Machine learning, the machine learning that we know of right now, was enabled because of coding, because of powerful computing. So learning to code, a must.
That's, we can say, the first step towards moving towards data science coding.
Absolutely. Or we can say one of the steps. I think there's no particular order. You can start off with anything, but it's something that you're going to need to be able to do data science. Specifically within coding, there are two paradigms. One is the computational paradigm, and the second is the retrieval paradigm. What I mean by that, you need to be able to code. You need to be able to code a logic, an algorithm, a flow, or way of processing data. For that, you have languages like R, Python, MATLAB. Python is by far the most popular and my personal favorite as well. With Python, the goal is, with Python, you're assuming you have data. And
Right.
with Python, you're just trying to manipulate the data. Second piece of programming or coding you need to know is retrieval, which is learning to retrieve data from databases. It can be classical languages like SQL, it can be MongoDB, Elasticsearch, or Cassandra, or anything, any big thing, any small thing. The idea is, as long as you know one of the programming languages for each, you know all the foundations, and then you'll be able to scale, build upon that knowledge. So if someone asks me, I'm very comfortable with Python right now, but there have been times where I've worked with other data scientists who use R, and I've been able to use R because the core thought processes behind what you do in Python and R is going to be the same. The way you write it is going to be different. Same with SQL, MongoDB, and retrieval languages. So definitely learn a computing programming language, definitely learn a database or retrieval programming language.
So basically, when you're juggling between two different languages, the thought process remains the same, but the syntax changes. So, I mean, when you're thinking about data science, you would think about it mathematically, but how do you represent it to a computer would be an essential step in the process of in one of the boxes that you need to tick.
Exactly. And it's like the goal is to nail a hammer into the wood. Coding is a tool. You can use a hammer. You can use any piece of metal to hammer a nail into the wood, right? So as long as you know any programming paradigm, you know how computers function and you know how to leverage them to do what you want. The next thing, but yeah, any comments there?
No, I think that's obviously the first step. That's granted. Yeah, moving on to the next step, or the next
The,
box.
the next checkbox is learning maths and statistics. Think of math or statistics as language in which you can communicate or represent the world. You'll hear a lot of statisticians say that math is like a language in which they describe the world, and somewhere that's true. That's very true in case of physics, but that's very true in case of statistics as well. And what I mean by that is math and statistics. We have probability, we have geometry, we have matrix calculations, we've got vector algebra, we've got calculus in general. Probability teaches you to think in terms of chances. When things are happening in bulk, the examples that we solved when we were kids, coin toss, card shuffling, they're not really, I'm actually really pissed at the way statistics was taught to us, because that's not what probability is all about. Probability is about law of large numbers. Probability is about doing things at scale. If I have a worldwide phenomena, how do I represent it? How do I try to think of a worldwide phenomena? A very simple thing could be, I'm 5 feet 10 inches, but what's the average height? Then you can go down further, you can look at average statistics, but then that is based on description. If you want aggregation statistics for events, what is the likelihood of sun rising from the east? 100%. What is the likelihood of you winning the lottery? Probably I'd calculated this, it's somewhere around 1 in 300 million.
Oh
right?
my
So
God.
it gives you a way of thinking. It teaches you how to think on a global scale in terms of large events happening. Sun rising from the east, 100%. Sun turning into a black hole in the next 100 years? Not really. 1 million years? Not really. 5 million years? Yeah, probably it'll turn into a black hole. So without the probability, we might not be able to think of these magnanimous things. Probability goes against first principles, where we are trying to break things down. Probability teaches you how to look at things as a whole. Geometry, matrix algebra, vector algebra teaches you how to define, how to play around with things beyond the 3 physical dimensions we live in. You can play around with different dimensions, and these things come in handy. There are algorithms like support vector machine. You can represent things in hypothetically n number of dimensions, not just 3 dimensions, 4 dimensions, 5 dimensions, so on and so forth. You can see things in multiple dimensions, not literally see, but a computer can, and it can figure out patterns, clusters, and so on and so forth. Calculus in general helps you. Calculus is very important if you're planning on doing any sort of deep learning, neural networks, anything. Calculus is important because along with maths and statistics, the way it exists, calculus is important to be able to translate what we know about human neuroscience. Neural nets are inspired by human neurons. They're far more simplified than human neurons. And just FYI, human neurons are far more complicated. Neurons which wire together, 100% a myth. Neurons are able to perform 10 different functionalities. Digital neuron is just able to send a signal one way, and receive a signal. But having all of that said, to be able to represent this complex mesh, we need calculus to be able to manipulate a set of neurons. All of these things are gonna help you understand your world. They're gonna give you a framework of looking at your world from a different point of view, because not everything is it's gonna be difficult to represent everything in 3 dimensions and the way we see it. So learn coding, learn maths and statistics, because it will give you the ability to play around with things. Learn math and statistics because it will give you ability to understand things, look at things from a different point of view. It'll give you, when we talk about out-of-box thinking, this is first step towards out-of-box thinking. Over time, this will become a part of your box, but you got to take the first step outside.
So you'd say, okay, first step outside would be out of the box, later it'll become a part of the box. Again, you'd have to challenge yourself to break the box and go out of that again.
And that's what fascinates me about data science. I've always been fascinated by different ways of looking at the world and understanding the world a different way. And data science just keeps on coming up with new and new ways to do this. We recently, or a couple of years ago, we took a picture of a black hole. It wasn't as simple as us pointing towards a black hole and taking a picture. There's a lot of math and science that has gone behind it. We are not looking at visible light spectrum. We are looking at a spectrum that's completely invisible to a human eye. But we are able to map it to a visual spectrum. It's a great analogy. It's not the reality. How are we able to build that analogy? How are we able to see beyond the visible spectrum? That's where the James Webb telescope, or whatever telescope was responsible for taking that picture, came into the picture. But beyond that, we analyzed the data. We figured out on each pixel what intensities are greater than what other pixels. So it was a relativistic analysis. We captured not just picture in one dimension. That was a solid camera. There was multidimensional data that was being collected. We did some sort of, and I'm oversimplifying this, we did some sort of a principal component analysis where this data, multi-dimensional data, was brought down into 2 dimensions. It was projected down in 2 dimensions. All of that made possible because of math and statistics. That's what math and statistics enables us to do. We can take things which are beyond our purview of sensing, which are beyond our 3 senses. Technology will enable us to collect data. Math and statistics will help us connect it to our understanding.
Right. I think that really puts a lot of things into perspective of how a new learner should go about them, and then broaden his field of view again. Because, I mean, the way that we think about mathematics is, a subject that's supposed to go away eventually. And what you're speaking about is bringing it in because of the entire world of fascinating possibilities that it can open up in front of us, and how many minute details we can look at when we're thinking about things like probability and statistics, which we never thought would be a part of, innovation in the world, but in fact they are. And those are the things that you really need to look at if you want to take that leap and if you want to think out of the box.
Absolutely. And like you said, right, being able to think and taking that step outside the box, that's science in a sense. And we are doing data science, right? So with my 3 senses, if I look outside, Earth is going to be flat. But if I took a more structured approach, started thinking out of the box, started looking at things from a new point of view, probably employed math and physics, of course, I get to know that things are not as simple as they look like. It comes down to our sensory system being very limited in its ability to do things. But having said all of that, the checkboxes are learn to code, learn maths and statistics, and finally practice, gain practical experience. See if you can get an internship, do some projects, do Kaggle projects, try and understand how these technical skills connect to real life skills, try and understand people. That's going to give you domain knowledge. So coding, maths and statistics, domain knowledge, That pretty much covers the entire framework.
Right. 3 things, and continuously keeping in touch with them, practicing them, applying them to real world situations. That's taking us to the next question about how, there's been kind of an eruption of AI taking over the world because now everyone wants to use it. You want to use it for, specific applications, like, say, what you mentioned about you were working in an automobile company, and that's really narrowing. Let's say you're not using AI to look at the entire web, but you're narrowing it down to one application. So now there's a huge AI boom, but then there are also lots of questions that have been formed about, how AI is impacting humans, which brings us to the ethical questions about AI, and how, it can be designed to be more ethical and more user friendly. What are your thoughts on this topic?
That's a great question. I think with the pace at which data science is progressing, data science, machine learning, AI, all three are progressing. We need to catch up. We, as human beings, we need to catch up. In the end, ethics comes down to having transparency, accountability, and privacy. With ChatGPT, accountability has been a big thing. Transparency, definitely. But I'll come back to accountability with ChatGPT here in a second, and how accountability is being dealt with in terms of ChatGPT. But before we talk about these things in detail, I think ethics and building resilient AI is a very tricky landscape. And I say that because there's lack of ethical knowledge, there's absence of legal frameworks, and insufficient monitoring bodies, which pose major challenges to what's happening right now. As humans, we've tried to build structures, frameworks, governing bodies to regulate things, but the rate at which the progress is happening and the time which we need to come up with frameworks and structures, they're far apart. I want to take a moment to talk about a very specific example, and the specific example is going to be ChatGPT, because everyone will be able to relate to it. ChatGPT does not understand what we ask ChatGPT. ChatGPT is not thinking when we ask it a question. ChatGPT is very good at taking my query, doing information retrieval, summarizing it, and giving that information back to me. It is not conscious, it is not aware, or it does not really understand what I'm asking. As a consequence, ChatGPT or any other large language model or any other AI tools that we see coming up, they're going to fail at assessing their own accuracy. They're going to be wrong a good chunk of times, but they're going to be right as well. It's our job as humans to be able to take the relevant piece of information and let go of other pieces of information. That's something that we call about, so when we say AI hallucinates, that is what it is. It basically comes down to the fact that AI is incapable of assessing itself. It's not that ChatGPT actually hallucinates. Journalists, media in general, we are very good at coming up with very misleading buzzwords. So AI does not hallucinate. There's not going to be any singularity anytime soon. But I want to pick on two large language models, ChatGPT and BART. And I want to talk about a very tiny feature that makes a world of a difference.
Right.
When you use ChatGPT and when you ask ChatGPT a question, if you notice, ChatGPT will type it out.
Yeah.
Is ChatGPT really typing it out? If I look at the back end, is the model really sequentially coming up with an answer? Not really.
No.
Right? So you give it a query, the model runs, the model has the output. Once the output is generated, it's a UI feature where we produce the answer as it's being typed. Let's look at another LLM, BARD, Google BARD. With Google BARD, you must have noticed that if you type a question, Google BARD just pops an answer out.
Yeah.
Right? Both of them are LLMs. Why is that happening? With ChatGPT, Microsoft has a great team focused on UI, UX, user interfaces, user experiences, human-computer interaction. So does OpenAI. And one of the reasons why this type functionality was brought into the picture is because there are additional layers. Once the large language model throws an output, there are additional layers which process and try to process and understand the response. There are checks being performed where if the chatbot is saying, if the LLM is saying anything unethical, that's being checked. There are algorithms or layers where profanity is being checked for, and so on and so forth. So it takes time for those layers to function. But even if those layers functioned at O of 1 complexity, if they were able to produce an answer right away, plan all along was to type the answer out. Why was the plan to type the answer out? What difference does it make if I type the answer out and show it to a user, or if I just show the entire output? It's based on our human psychology. The answer is being typed out because there's a phenomena called cognitive forcing that was to be employed. What does cognitive forcing do? Cognitive forcing basically enables us to employ our own thought process. Let me give you an example. If I ask you right now, what are you thinking about? There's probably a jumble of things going around in your head.
Yeah.
We're probably not even conscious about it, right? Now, if I ask you, Aditi, be very conscious of the next thought you're going to get. How does it feel?
Well, I think I will hyper focus on, what's going to be next. And I want to, go out and grab the thought and I say, okay, this is the answer.
Right. So you're being more intentional, more thoughtful. Probably things in your brain, the resources in your brain are focusing, instead of hundreds of thoughts happening here and there and us autonomously just existing, we become hyper-focused and be more intentional, be more thoughtful about what's going on in our brain, right?
Right.
Because we knew that ChatGPT could sometimes be wrong. AI will hallucinate. AI will not always give the information we want. What was needed is for a human to be able to, when ChatGPT responds, we wanted humans to be able to employ their own mind, be more thoughtful, be more intentional about the answer that ChatGPT is throwing back at them. So typing an answer out enables cognitive forcing. You are going to be far more intentional, far more thoughtful while ingesting that answer. Now, who made this happen? Who came up with this idea? People who know human mind, people who know psychology, people who know cognitive sciences, people who understand human-computer interaction, people who do UI UX, people who don't necessarily know machine learning or who don't necessarily know how to do machine learning. They know enough about machines, they know enough about humans, and they can make things happen. With Bard, that is not the case. Bard, when it throws an answer at you, you get busy just consuming the answer. You're not gonna be thoughtful or intentional. You're not gonna assess the answer that's coming at you. What is the point of all of this? Being able to do resilient and ethical AI is not just about AI. It's about humans as well. As the field of AI progresses, we need more people who understand humans. We need people who understand cognition. We need people who understand human psychology. There are fields out there, UI UX, human-computer interaction. You can even study psych to be able to contribute to AI. So to sum it up, building resilient and ethical AI, people are generally afraid that a lot of people are going to lose their jobs and so on and so forth. But my point of view differs a little bit. I think there are going to be more jobs focused on making things easier for humans. There are going to be less jobs that make us work with machines. We're going to have more jobs that make us work with humans. And people can contribute to AI not just by studying machine learning, mathematics, coding. You can contribute to AI even if you're interested in psychology, even if you study psychology, even if you study human-computer interaction. So in summary, AI is not just about AI. AI is not just about building complicated systems, doing math, statistics, and coding. AI going forward is going to be much more holistic. There are going to be many jobs that are going to be focused. There are going to be newer types of jobs and more jobs that are going to be focused on understanding human beings. So if you want to contribute to AI, you don't necessarily have to do maths and science and coding. It can be a people job as well.
Right. I think that's a really, really interesting answer because, first of all, because of the perception of people that, now AI is taking over the world, everyone's going to be out of jobs. And, the machines are going to start doing everybody's job. But I think, again, then there's the aspect of teaching the machine how you're going to do the job is something that we as humans will have to teach it anyways. And I think it's a very good point that you emphasized on how ChatGPT, types out the answer, and that enables three things at the same time. One is buying time for their checkouts about whether the answer is propagating something misappropriate, and so that will be one thing. Another thing is capturing people's perception and giving humans the ability to think that, okay, this is something that someone is telling you. It might be right. It might not be completely factually correct. So you might want to do another fact check. And another thing would again be, for humans to familiarize it with someone that's talking back to them. Right. So basically, if I run a Google search, it's going to throw a website at me with the thing that I've searched for. But when you're thinking about ChatGPT, it's going to give me a summary and it's going to create the notion that it has understood something, and it's kind of providing me with points that are based on its understanding. So these are three things that I think it's a great way that AI is being looked at from all of these different perspectives to create a product. I think that's what you wanted to emphasize in this answer. And again, to one more point that you really wanted to speak about, causal AI. And how do all of these rules come into building causal AI? What do you think is the way forward?
Well, that's a great question. Causal AI, I feel like, is going to be the next big thing. And before I talk more about causal AI, I just want to clarify, it might seem like a Microsoft employee is dissing on Google Bard, how typical, but both of them are great tools. It's the next step in humanity. Google Bard does some things better. ChatGPT does something better. In terms of human-computer interaction, I feel ChatGPT has a more holistic point of view. And working at Microsoft, I have some visibility to how the back-end functionality is. And just FYI, OpenAI built it. Microsoft was a partner, but that still gives me a better understanding of how things work. So pointing it out was important. I think having an understanding about what resilient and ethical AI means, what steps are happening right now in building resilient and ethical AI is important. We cannot ensure that AI is going to be always ethical or always resilient from within the model itself, but we can resort to our own abilities, our own judgments, our own cognition, which is far superior than what these models can do, which I think which is a great segue to causal AI, human brains, right? Right now, if you look at the state of machine learning AI, we've talked about how ChatGPT cannot really understand what I'm saying, but it's going to be great at retrieving information, summarizing it for me, trying to do some sort of reasoning. Human brain is far more complicated, far more capable than that. We have consciousness. We are able to reason with ourselves. So with ChatGPT, there's a reinforcement learning element to things as well. So there are penalties and rewards. If you are training a cat, you can give cat punishment or penalties based on what you want the cat's ideal behavior to be. With humans, that doesn't really stick because cat is gonna take punishment for what it is. It's gonna take a treat for what it is. A human can think for themselves. A human can figure out that I can question the rewards and penalties by myself. With causal AI, we are trying to build a new paradigm where the goal is not to have an objective function where the reward and penalty is specified, but the goal is to model a more meaningful, more insightful insightful world. And I want to give an example of what does not look like causal AI before we talk about what looks like causal AI. Something my professor used to say during my master's, Dr. Rishod Golden, is the quickest statistician is the statistician who wakes up every morning, he sees the sunrise and ends up concluding that the sun rises because of him. Classic correlation versus causation, right? Just because there's a correlation that I see the sunrise after I wake up does not mean me waking up is causing the sun to. Causal AI tries to resolve this problem by being able to model a more meaningful world. One of the ways that's being done is, imagine if we had a more comprehensive understanding of the world. Imagine a graph where before I train a machine learning model, the model already understands some foundational truths. That sun rises from the east, sun rises because Earth spins. It has some basic understanding of physics. It has some basic understanding of how things interact and function with each other. And based on this embedded prior knowledge, I give this model some data and ask it to explain things. How are things going to be different? Instead of me drawing insights just based on correlations, sometimes correlations are misleading. But because I have some world knowledge embedded within me, some nonsensical correlations, the model is going to be able to throw out of the window right away. It's going to be able to try to explain things more meaningfully, more insightfully. That is where some abilities of truly understanding what's happening comes into the picture. So causal AI, I think, is going to be the next big wave. One of the key ingredients for causal AI is going to be for us to model world knowledge. There's research being conducted, or there are academia is right now focusing on trying to embed some world knowledge in form of graphs, where we have graphs as different entities and we have interactions between nodes between the graph depicting interactions. And just to give a simple example, we have a very mature graph for human body. We have a knowledge graph called SNOMED CT or UMLS, Unified Medical Language System, where there is a hierarchy of human body, human anatomy. There is a hierarchy of different illnesses a human body can have. There is a hierarchy of what different medicines can do to different parts of bodies and different ailments. So to give you an example, what we can do with UMLS is I can ask UMLS, and UMLS has a different coding language. It's like a database search on this graph. But you can imagine I'm writing a query, right? And I'm writing a query where I'm like symptom, coughing, location, lungs, and based on this, give me all possible illnesses that are connected to these two symptoms. What the graph is going to do, it's going to pick out lungs. It's going to pick out another entity, another node, coughing. It's going to see whether coughing can really happen to the lungs, because you can as well say that I'm having a headache in my stomach, but that's not going to make sense, right? So it's going to figure out if my query is making sense. And then it's going to look at another graph that has connections to these two nodes. Who made this graph? Doctors. UMLS has been in progress since 1990s, where doctors, technicians, people who work in biotech domain, they've been trying to embed knowledge continuously in this one big graph. And now we've come to a point where we can do some sort of auto-diagnosis, coughing, lungs, give me all possible illnesses. There are going to be a lot of illnesses. You can narrow it down, coughing, lungs, ache, left lungs, blah, blah, blah. And then it'll filter down the connections, give you more and more meaningful insights and so on and so forth. And you can build upon these graphs to do data inferencing. So you can take population data, or actually, as a matter of fact, let me quote COVID. Building vaccines for COVID was accelerated because we had this knowledge graph available to us. When we were synthesizing the chemicals or the COVID vaccine, this graph let us know that what chemicals, what synthesized molecules in the vaccine is going to have what kind of interaction on what different parts of body. And then there were measures being taken to resolve those things. There were different types of molecules which were being tested. The testing was simulated. We didn't do real testing initially. The simulation testing was enabled by all of these tools. So that's where causal AI is going to take us. And it's going to be the next big wave. It's not going to be the same as a human understanding another human, but it's gonna be not as dark.
So I think the crux of causal AI would be you are initially giving your model a lot of different correlations on which it can base its next answers. So in context of what you spoke before about, the model has 4 steps, and there would be a phase where you're just understanding the problem, you're diagnosing the problem, then you're trying to, predict what's going to happen next. So I think that would be a very good connection to this, wherein you think about, okay, so I'm going to throw in a lot of more correlations, which the model is first going to process. And then based on that, it's going to say, okay, this is what's going to happen based on all of the extra knowledge that I now have, which I didn't have before.
That's absolutely it. One thing though, I'm going to be a bit careful around using the word correlation, because what's going to be fed to the model, the priors for the model are going to be carefully vetted knowledge and understanding of the world. It's like giving models domain knowledge. And this knowledge is not just going to be a set of random correlations. It's going to be carefully vetted knowledge. So you can as well say that it has one of the prerequisites is models inherent and ability to, we're going to feed some causal data, and then it's going to do some causal analysis based on the causal data we feed it in. So it's like training a human baby, where we are telling the human baby how the world works without us telling a human baby that apple is meant to be eaten, banana peel is supposed to be thrown out. A kid can very well take fruit A, apple, eat it whole, take fruit B, banana, and eat it whole. So we have to tell the kid that both are fruits, right? Apple you can eat whole, banana you have to peel and eat. So these intricacies and the baseline world model is something we are going to causally would accomplish making. And it sounds scary. It sounds like it might give rise to Matrix, a new entirely simulated world or something. But it's just a scaremonger. I think we'll see what it's truly going to be able to do when it comes in. I believe that it's going to be very helpful.
Right. But having said that, would you say that ChatGPT now is based on the sources on the web, right? It's just a lot of different sources that are being put together and being fed into it. And then it can, based on the majority of sources, it'll give you one answer. But when we're thinking of causal AI, would the sources of information that are being fed to your model would be rather different, would be, something that's been completely verified by people who are feeding it?
Yes. So it's not going to be verified by the people. There are going to be other tools and techniques to verify that knowledge. We, as I believe, as humanity, we are going to come up with ways to automatically come up with a new way of coming up with structured knowledge. And that's the thing. With ChatGPT, there is no structured knowledge. It's just a dump of the entire text human has visibility to. That includes textbooks, it includes web pages, and then carefully crafted as well. What causal AI is going to accomplish is, instead of the data being unstructured, we are going to have to first come up with smarter ways of bringing structure to that knowledge. So AI build models that take random data and create structured knowledge for other models to consume, so that these other models are going to be specialists. They can specialize based on carefully crafted, well-structured knowledge, and they can be highly accurate, and they can be highly empathetic towards the way the world works.
Yeah, I think that's a lot more understanding into how the world is going to go forward with AI, especially addressing the concerns, addressing the problems or challenges that we have with AI today, and then moving on towards resilient AI, which will also employ a lot of more people in different fields. And that's really an interesting answer. So Abhiraj, you've given us an overview of the latest and greatest trends that are going to govern the future of AI. But what do you think are the key takeaways here for, people who are trying to break into this field?
That's a very good point, because these are the latest and the greatest things. Cherry picking on the technical front, what is happening on the latest horizon. For people who are trying to break into the domain, you should use this piece of information as a piece of knowledge where mechanical automation back in 19th century led to industrial revolution. Right now with AI, what's happening is information automation, where information can be processed at scale automatically, where information can be produced, relevant information can be produced quickly, and so on and so forth. With the latest advancements, no one is going to have to go to library and scan for books and read the entire book to get the precise information that they want. With all of this, we are at a time where we are undergoing an information revolution. As someone who's trying to break into the field, remember to make the best use of industry information revolution. Information revolution is going to happen irrespective of whether we like it or not. Because in the hindsight, it's good for humanity. We are not meant to be a memory device. If you ask a neuroscientist, a well-seasoned psychologist, what they're going to say is humans are meant to be a computation device. So we are offloading that memory overload, the rote learning, all the things that are difficult naturally to us, we are offloading it to machines. With that, remember to stay with the trend, go with the revolution, make the best use of it. Remember, if you would like to contribute to it, there are various ways to contribute to it, not just math, statistics, and coding. You can understand humans and contribute to it. So those are some of the key takeaways I'd like to highlight for someone who's still trying to break into AI. And on a closing note, I think it's wiser to think of AI not as AI. If you think of it as cognitive sciences, it's gonna make more sense. Cognitive sciences offloaded onto machine.
Right. I think that's another, a great way to look at how AI is going to move forward, and with it, the entirety of humanity will have to catch up with it. And how do students make the best out of it, capitalize on how AI is progressing today? Having talked about all of these points on a very large scale, I'd like to know, what does a day in the life of a data scientist look like? And what are some of the things that you do on a day-to-day basis at your job? What keeps you motivated to, be a data scientist every single day that you wake up?
The daily grind, huh? So I get this question a lot, and I wish I could tell you that every day is full of eureka moments, groundbreaking discoveries. But the truth is it's not. Like any other job, being a data scientist involves a combination of mundane things and exciting things. On a high level, if I look at the past 1 year of my life, I can say that I can categorize my professional time into a 70-30 bucket. 70% of my time is spent on technical things, on doing data science, on doing the lab coat or wearing the lab coat or playing around with things with screwdrivers. 30% of the job is people. And I'll expand on it a little bit. Why is people 30%? For me, I have 4 or 5 years of experience. I've come to a point where 30% is comfortable for me. When I started off working, giving 5% of my time to people felt like a pain. I just didn't want to deal with people. And when I say deal with people, it comes down to understanding your stakeholders, understanding the domain, understanding the problem statement, understanding the space in which your solution is going to apply, making sure that you and the stakeholders are moving together towards a product that's useful, right? If I want to build a car, one way to think about it is we can think of the bike analogy, right? I bring all the parts together, put them together, and just give the bike to someone. That's not how it works. Generally, the very first step is trying to see if I can make a wheel, because parts are barely available to me right away. First step is making a wheel or discovering a wheel. Second step is making a skateboard out of it. Third step is replacing a human foot on the skateboard with somewhat of an engine. The next step is having a seat where a human can actually sit with the engine and wheels in place, figuring out how the engine is going to transmit power to the tires and so on and so forth. So when doing all of this, I cannot lose sight of what is it that people actually need from me. Because if you're not aware of what people need, and if all you want to do is the cool things, build fancy models, build exceptional data insight, a calculation engine and whatnot, right? If you want to do cool things, you might end up doing something like you'll get the wheels, you'll put the engine on it, but you'll have no seat. A person is not going to sit on the engine. Neither is a person going to sit on the tire. What's important is how are people going to consume your product. A little bit of project management comes into the picture. A little bit of people management comes into the picture. A little bit of understanding the domain. A little bit of job shadowing comes into the picture. And all of that is 30% of the bucket. 70% of the bucket is not all cool bucket. If you look at the 70%, I'd say 20 to 30% of my time is spent in finding the right data, doing pre-processing, cleaning the data, doing some feature engineering. And all of that is very mundane. It's manually looking at things, cherry picking, transforming things. It doesn't feel as good, as cool. It's still relatively mundane. But there are days where once I have the data in the right format, once I understand what the problem statement is, once I understand what needs to be built and where is it going to be deployed or who is going to use it, once all these foundational prerequisites are in place, that is when the cool part starts, which is roughly 30% of my time. On best of days or best of times, that goes up to be 40%, but I don't think it goes beyond 40%. But once these foundational things are in place, which requires 70% of your time, sometimes 80% of your time, that is when the experimentation starts. That is when you start to look at models. That is when you start to plug models in with the data. You see how the model is performing. You get to validate the model. You get to judge the model. You get to grade the models. You get to experiment with different models. You get to look at a decision tree versus how a neural net is performing. You get to do feature engineering. You see all these cool things happening really quickly. And one thing I'd like to mention is the world of data science is at a point where these things can happen really quickly. There are Python libraries which you can use to really speed all of these things up. It's cool to see these things. It's cool to get your hands dirty with those things. But that is my day-to-day. 70% of it is mundane work. 30% of it is cool. So that's about my day-to-day. How does that make you feel about data science?
Well, of course, I think having put all of the things that you said earlier, I think for any task that you do, there's a fair amount of pre-processing that goes in, but ultimately, you have a bigger goal at the end of the day. And if you have to do all of those mundane tasks in order to get there, because those are prerequisites, I think that's something that we deal with on a day-to-day basis in most of the things that we do. And yeah, I think it's relatable to what we've spoken before, but I'd say that's what you would say about your motivation as well. That after all, it's what you're gonna deliver at the end of the day, which is the key motivation to why you do all of these tasks, which may not sound that interesting but are necessary.
And absolutely, I think that is a huge part of my motivation. And something that keeps me going and something that's a bigger part of my motivation is the impact. You can spend 3 to 6 months working on a project. And it's easy data science projects can be big, they can be small. It can take as little as a couple of weeks. It can take as much as 6 months to build and deliver a data science project. And most of that is not the most exciting part. What I discovered is data science can be a high risk, high reward job. And let me give you an example of what I mean by that. At Microsoft, one of my most recent projects was about capacity management. And let me talk a little bit about what capacity management means. We are in the cloud business. I work for Microsoft Azure. Our job is to have globally as many computers as possible so that people can spin up virtual machines and do their thing. What we promise our users is infinite capacity. Is capacity really infinite? Not really. What we do is we generally predict how much demand is going to be there, how many people are going to use Azure. And based on that, it's generally a range. On an average, 700, 300 million people are going to use Azure Core. They're going to spin up XYZ amount of virtual machines. Worst case scenario, it's going to be 400 million. Best case scenario is going to be 200 million. So what happens is based on the demand that we are anticipating, we try to bring in as much capacity as possible. We build in servers in our data centers, which are as massive as villages. And in one of these projects, what I was doing is there are going to be times when out of the blue, you see that the demand is too high than the capacity you can bring in which case, when a person comes on Azure and tries to spin something up, they're going to witness a failure, which is not what we want. So what do we do in that case? There are two things. We can be aggressive on our capacity planning, or planning more servers to come and dock into the data center. But capacity bringing in data centers is not straightforward. It can take anywhere between 6 weeks to 6 months for a new server to come in. Although we are one of the world's largest technology company, we still can't make servers appear out of thin air. So what happens at 6 weeks to 6 months time frame? Let's say you are one of our customers, I am one of our customers. We are going to have to fight for capacity. Either you're going to fail, or you're not going to get a VM, or I'm not going to get a VM. So there is something called as capacity management playbook that comes into the picture, where the more important customers are going to get the first pick at the capacity. Azure rolls out free trials as well, right? As a student, you can come into Azure, you get $150 worth of free credit set, and you can use Azure. If we are capacity gapped, if our capacity is limited, we'll try to block that demand. We'll say that, hey, more important customers are going to be using our capacity right now. Can you come back 3 hours later? And the same thing happened when COVID happened. We had to assign a lot of capacity for more critical functions to hospitals, to research, medical research labs to conduct their research, and so on and so forth. There were points when websites, retail, e-commerce websites had to be said no because there was more critical work happening on the back end. This is all capacity management, and up till now, all the capacity management was manual. My job as a data scientist was to come up with a system to automate capacity management, to automatically recommend and execute strategies to capacity manage. So that's the project. And building this project was painstaking, collecting the data, making sure, coming up with an algorithm, coming up with simulations, what if scenarios, coming up with the right strategy, backtesting the strategy. It wasn't easy. It was exciting on some days. It was mundane on some days. But once this project was rolled out, once this project became successful, there are more than 5,000 people for each data center who consumed the outputs of this algorithm. So there are more than hundreds of data centers all over the world. Each data center has more than 5,000 people working at each data center. And what I built helped those 5,000 people, or a lot of people, hundreds of data centers, roughly 5,000 people in each data center. What I was doing was helping them manage capacity on that. It was helping them predict times when there are going to be capacity gaps. It was helping them be proactive. It was helping them with strategy recommendations, and it made their jobs a lot easier. At the same time, if my recommendation is wrong, their job gets impacted. So with data science, you get to work on a very high level. You're sitting on top of a lot of hierarchy. Most data scientists get to impact several hundred people minimum. And that is what I think keeps me motivated.
Yeah, I think that's a very interesting answer in the context where you spoke about COVID and how this capacity management impacted, the specific time where people were working in a crucial situation. I think now it makes a lot of sense to do the mundane tasks as well. Moving on to the last question, what do you think are some very critical points of advice that you can summarize for the next generation of AI and engineers?
AI and data science is as vast as it could be. Although it's not going to include physics, it's not going to include neuroscience, it's going to be technical, it's going to be people-oriented all at the same time. So everyone has a place where they could contribute. Having said that, something that we talked about in the podcast about AI data science projects being overwhelming. From a both side perspective, a lot of things seem overwhelming. It's okay to take time. It's okay to not know things. It's not okay to give up. Take time, break things down, ask questions, be consistent, experiment with your own approach of learning. Remember to play around with scientific methods, first principles thinking. They're gonna help you a lot in your future journey. If you decide to contribute to AI, they'll help you feel not as anxious, be more comfortable with the complexities of the domain. But most importantly, data science is not going to happen overnight. You're not going to wake up today and tomorrow you're going to know data science. I can't say with 7, 8, 9 years of exposure to data science that I know all data science. Probably know 30%, 40% at max. That's good enough. So think about what you're passionate about. Figure out what drives you. Be consistent. Keep on learning. Network with people. Ultimately, the goal is to keep on growing, keep on learning, and make a positive impact on the world with any skills you have. And right now we are talking about data science. Data science, think of it as just another skill. Those are some of my top of the mind.
Right. I think that's a great way to sum up what we spoke about in the podcast. And that's a great way to move forward for people who are still new, still moving towards, something that they're just passionate about, but, are still navigating their way through it. Thank you so much for this conversation, Abhiraj.
Absolutely. It was a pleasure.
Thank you for tuning in to this episode. If you found it valuable, I kindly ask you to share it with others who may benefit from it. I highly recommend subscribing to our channel and exploring our other podcasts, all designed to support the student community. Additionally, make sure to visit the description for important links that will connect you with us. We look forward to seeing you again soon. Wishing you a wonderful day ahead.